Okay. So why should we care about streaming? So today I'll be talking about what is streaming, history of streaming, Apache Kafka concepts, and as well as why you should actually care about streaming. And then hopefully if I get some time, I can get demo running. So what is streaming? In data engineering, streaming refers to a continuous ingestion, transport, and processing of unbounded sequence of events as they are generated. Unlike batch processing, which operates on static datasets at scheduled intervals, streaming systems handle data in motion, enabling near real-time transformation, aggregation, and analysis. So, a brief history of streaming. We're just going to start from the 1970s to the 1980s. So during these days, applications wrote events into relational databases like MySQL, Postgres, Oracle, and other systems checked for changes by polling the database. So this was very suitable for small workloads like 50 years ago. But like as you guys can see, this presents a huge problem as there are problems with high DB load, there's slow detection, and real time meant hours or even minutes. Coming on to the next era of streaming, we had message queues. So with IBM MQ, TIBCO EMS, which was later RabbitMQ, which some of you might know. And this basically was a point-to-point messaging and publisher-subscriber models. It provided reliability, guaranteed delivery, and decoupling of services, but this also had limitations. It was harder to scale horizontally. There was no replay. Messages were deleted after consumption, which presented the problems for enterprises in this era. And then coming into the 2000s, so in this era, we had the Enterprise Service Bus from, I think, IBM, I believe. So this handles routing, transformation, orchestration between services. It became a bottleneck and a single point of failure. And then we had ETL pipelines with the Informatica SSIS. So basically, this moved data into daily or hourly batches into data warehouses, and then analytics and dashboards were delayed by hours or days just from using the data. And then post the 2000s, we had 2010 to 2011. So this was where the first attempt at data streaming was made. So Twitter developed some system called Apache Storm. Um, and there was Scribe came out during this time. So all these tools that came out during this time enable continuous processing of streams, and it was used for real-time dashboards, monitoring, and log aggregation. But obviously, it had weaknesses. It was complex to operate. It lacked persistence. It was very fragile at scale. Moving over to the post-storm era, which is the 2011 and upwards. So here we had distributed and durable event log with publisher subscriber. We had replayable messages, which messages were not lost after consumptions, which the previous eras faced with this. And we can scale to millions of events per second with fault tolerance. And this became the backbone for real-time data pipelines and event-driven systems, as you will see in the next eras. And in this era over here, which is post 2015, streaming processing frameworks came through. We had Apache Flink, we had Spark Streaming, KSQL DB, and then we had next gen brokers, which we still use today, like Red Panda, which are Kafka compatible, low latency. And this era basically had the tools to like be able to power for fraud detection, personalization, IoT, ML, and monitoring. And it had event-first architectures. So microservices were communicating through streams and unified real-time and batch roles into a single ecosystem. Okay, so this is the era that we are in now. So when you going through the rabbit hole of going through streaming and learning about all these topics, a center theme comes through, which is Apache Kafka, which was created by this guy over here. So basically, Apache Kafka is an open source distributed event streaming platform designed to handle high throughput real-time data feeds. It was originally developed at LinkedIn to process massive amounts of user interaction data. and it has evolved into a robust solution used by over 80% of Fortune 100 companies. And basically, it serves as a central nervous system for modern data organizations, enabling us to collect, store, process, analyze streams of events at scale. And good to know thing is this thing is really cool to like work with Flink as well, which is another tool that you come across when you're diving into the research. So here I'll be just talking about the core concepts of Apache Kafka. So we have events and topics for here. So basically, most streaming platforms basically follow these concepts. So an event represents something that happened in the real world, such as a payment transaction, a website click, sensor reading, or any other noteworthy occurrences. So in Kafka, events are typically represented as key value pairs and are often serialized with formats like JSON and Avro protocol buffers. Then we have topics, basically. So topics are like channels in which we publish our events to, and they serve as the fundamental organizing principle for Kafka. So basically, it allows producers and consumers to focus only on relevant data streams. So for example, a retail application might have separate topics for orders, inventory, and user signups. And going into this, let's say perhaps you're building an analytics system, you could have topics for those events for your users. If your user base is developers, for example, they can like you can read topics from the user events. And we have partitions and brokers. So each topic in Kafka is divided into partitions, which are ordered immutable sequences of records. So they serve two purposes. They enable parallel processing by allowing multiple consumers to read from a topic simultaneously, and they distribute data across multiple servers for scalability and fault tolerance. Then we have brokers that are basically just the servers that form a Kafka cluster. And brokers host some of the petitions from various topics and handle requests from producers, consumers, and other brokers as well. And we have producers, consumers, and consumer groups. So basically, a producer, basically what it says it is. So these are programs that publish events to Kafka topics. They can choose which partition to send messages or allow Kafka to handle distribution based on the message key. Then we have consumers, which are basically applications that subscribe to topics and process the published events, and they maintain an offset in each partition they consume, allowing them to control their position in the event stream. And we have consumer groups, which I haven't used much, but they allow a group of consumers to collaborate in processing messages from one or more topics. So Kafka ensures that each partition is consumed exactly by one consumer in the group, facilitating parallel processing while maintaining order delivery within a partition. So why? Why am I talking about this? Why should you care? So the real reason why you should care, obviously, with most of you knowing, is like the real-time thing that we talked about, the fraud detection, anomaly detection, monitoring in milliseconds, scalable architectures, decoupling producers and consumers, and replay and reliability, as we talked about, that we can actually replay some of these messages. And over here, it's powering modern use cases. A lot of big tech companies use streaming applications like Kafka and Flink in today's world, and also future-proofing skills. Like the nicest thing about this technology is that not many people know it, not many people care about it, but it is so fundamental, especially in big tech and building enterprise software. And obviously for event-driven systems, we can move away from, polling, making like a request and a response to reactivate real-time pipelines. So I still have time. Okay, I'll be doing a quick demo right now. Okay, so here I have a basic Kafka application that was built with Flake and Kafka Python. So what this does basically is just like a simple consumer and a producer. So the producer produces the messages and we send these messages to an endpoint using Flake. And then the consumer with Flake as well and some other tool is able to like just make a web page for that for us to be able to see these messages. So I'm just going to be testing this right here. Okay, the API is running. And I'm going to be sending a message right now. Um, Hello world. Okay. Okay. So I can just open up the setup that Kafka job, Kaf job. So if I can just view my messages, we can see that like below over here, it sent a message. So just a quick run through over the code. Basically, okay, we have our consumer, we have our producer, publisher. Okay. So here I was just defining the message object and the router that we should use. So as you guys saw, the message has like key values, which is the name and description. Yeah, which is the name and description. And then also implemented Kaf drop and Kafka as well in the consumer to be able to just read the messages. And yeah, that's just a basic setup of Kafka with Kaf drop and Flake. Thank you guys.